Good afternoon, class.
Good afternoon, sir.
Today we're going to be looking at a new topic. We're going to be starting with algebra. Alright? And before we start, I just want to go through some lesson outcomes with you. By the end of this lesson, you should be able to use algebraic language. You also should be able to recognize and identify conventions for writing algebraic expressions. And you should be able to recognize and identify coefficients, variables, and exponents. Alright, let's start. What is algebra? Right? Algebra is a section of mathematics. It's the part of mathematics in which letters and symbols are used to represent numbers, quantities, formulae, and in essence to form an equation. Right? These are all symbols. Right? What symbol is that?
The sun.
And what symbol is that?
Thunderbolt.
And what symbol is that?
A heart.
And what symbol is this?
The moon.
A moon, right? These are all symbols. Do you agree?
Yes.
But are they mathematical symbols?
No.
No.
Not necessarily, right? Not necessarily. Let's think about a process, right? Let's say in this class you're all grade 8 and you're all grade 8 learners, I'm assuming. Some university students, but mostly grade 8 learners. I'm guessing you're going to be choosing subjects next year, right? Now let's say for every student that takes physics, for example, or for every student that takes maths, there's 5 students that take geography, right? So if you take maths, 5 of your peers will take geography, right? So we can take any number times 5, and that will tell us how many students are taking geography. Right? Let's look at an example. Let's say 3 of you take maths, right? How many students will take geography? Someone raise their hand. How many students?
15.
15, right? Because we took the number 3 and we multiplied it by 5 to get 15. Now, can't we say, we can say any number times 5 and that gives you an answer, right? But isn't there a better way of saying this, right? In mathematics, can't we say that it's something times 5, right? In this case, a smiley face, but it could be anything times 5, right? So it's something times 5. We have to be careful in mathematics to always be mathematical. Right? We need to speak mathematically. So in this example, let's say there's 5 students that take art, right? For every student that takes maths, there's 5 students that take art. We can represent that as 5a. When numbers are next to it, when a number is next to a letter in maths, right? It's the same as saying 5 blocks or 5 boxes of something, right? It's 5 times that number of boxes. Right? So in this example, I said art could be 5a. Maybe for every student that takes maths, there's 3 students that take geography. For every student that takes maths, there could be 5 students that take art. Right? And likewise. Now, what happens if the same is true for every class? Right? So for next door, there's mathematics as well. In that maths class, for every 1 student that takes maths, 5 students take geography, right? But it's the same for every class. So for this class and the class next door and the class next to that. Wouldn't you agree with me in saying that it's 5 times the number of students in this class, plus 5 times the number of students next door, plus 5 times the number of students in the class next to that, right? You agree with that? And we know that something times itself 3 times is that something to the power of 3, right? That's an exponent. I want you also to remember something. If we have 5 times something, right? In this case 5x, that's the same as saying 5x to the power of 1. Anything raised to the power of 1 is someone? Itself, right? It's itself. Okay, now this is an important slide. I want you to take note. When we have a number, when we have a constant, so we call it a coefficient, that's a number before a variable, right? Then we have a variable, and then we can have that variable raised to an exponent. In this case, the coefficient is 5, right? And our variable is x, and our exponent is 1. It's important to note that a coefficient is the number before a variable, right? A variable could be anything, right? It could be any number, any quantity. It just represents something. And then similarly, an exponent. An exponent is just a power given to an expression, right? So it's that times itself some number of times. Let's look at some examples. So what we're going to do is, I want your help to identify the three things we discussed now. The coefficient, the variable, and the exponent. Let's look at this first example. 5x to the power of 1, right? What is our coefficient here?
5.
5. And what is our variable?
X.
X. And what is our exponent? 1, right? 1, well done. And what have we noticed? We noticed that the coefficient is before the variable, and that variable is raised to an exponent. This time it's 1, right? This could be the same as 5x, right? Because we noted in the previous slide that 5x is the same as 5x to the power of 1, right? Let's look at another example. What's the coefficient here?
25.
25. And what's the variable?
X.
X. And what is the exponent?
3.
3. Well done. Let's look at another example. This one's a bit more tricky. What's our coefficient?
2.
2, that's right. And what's our variable?
X.
It is x. And what's our exponent?
0.
0, right? We can have an exponent of 0. It doesn't mean that it doesn't exist, right? We can have an exponent of 0. It just means if something's to the 0th power, it just equals 1, right? Anything to the power of 0 is 1. Let's look at the last two examples. 5y to the power of 3. What's our coefficient there?
5.
5.
5. What's our variable?
Y.
Y. Do you notice that it doesn't always have to be x, it can be something else. And what is our exponent?
3.
3. Okay, the last example. What is our coefficient?
25.
25. What's our variable? In this case, our variable is
Z.
z, right? It's z. And what's our exponent? 5. Well done. Well done.
Sir,
Yes.
you mentioned that a variable doesn't necessarily have to be X. So does that mean it can be any letter of the alphabet?
That's true. A variable could also be something like Q or R or T. It could be any letter, right? It doesn't always have to be X.
Okay.
It's just any letter of the alphabet. We use the Greek alphabet usually when naming variables. All right. Let's look at some interesting facts when it comes to algebra, and namely algebraic expressions, right? So we're able to identify coefficients, variables, and exponents, right? We can do that because we've just practiced it. Now, algebra is cool because you can take like algebraic terms and add and subtract them. You can do that, right? Let's say in this class I've got 5 happy math students, right? And if you're a happy math student, let's call you X. What happens if I have 5 happy math students and I add another 5 happy math students to the class? That gives me 10 happy math students, right?
Yes.
Similarly, we can say 5 happy math students plus 10 happy math students, and that gives you 15, right? If I've got 5x plus 10x plus 15x, what would that give me? How many happy math students? 30, right? 30 happy math students. Let's do some examples. You can tell me the answer. So if I've got 5 happy math students plus 6 happy math students, that's how many?
11.
11. And